Hi all, this is April. Today I am presenting to you a recap of my fieldwork and my research presentation. My fieldwork was with the study Diet and Cancer in New York City Minority Populations. The study is a collaboration between the Biological Sciences Department, the Nutrition Program, Hunter's New Center for Cancer Health Disparities Research, and Temple University's Fox Chase Cancer Center. Here we have the principal investigator, Dr. Ogunwabi, and the co-PIs, Dr. Navder and Dr. Ye. The study investigates the hypothesis that a dietary and nutrition education intervention is associated with reduced cancer risk. There are two aims to the study. Aim 1 assesses dietary behaviors of adults ages 50 and older in East Harlem and the correlation to colorectal cancer using a validated FFQ and the biomarker gallic acid, a polyphenol that is found in some fruits, vegetables, and tea. Aim 2 assesses the impact of a 16-week intervention with nutrition education and cooking demos on the gallic acid biomarker and BMI, both of which are associated risk factors of colorectal cancer. The intervention's effectiveness will be assessed by comparing pre- and post-intervention results. We are currently wrapping up Aim 1 now. My role in the study is research coordinator. I work alongside the principal and co-investigators of the study. I prepared written materials for the research assistants' orientations and organized 2 orientations. I coordinate the recruitment visits. I manage and organize all study materials, participants' personal info, and also input and code all FFQ and demographic data. I helped prepare an oral presentation and attended the 2nd annual Temple University and Hunter College Regional Comprehensive Cancer Health Disparity Partnership Research Symposium. And I also helped to develop the study's research manuscript. Here we have some members of the recruitment team. Diet has a strong effect over the risk of colorectal cancer. Red meat, processed meats, preserved foods, animal fat, high-caloric diets, and refined carbs have all been implicated as risk factors for colorectal cancer. And fruits, vegetables, calcium-rich, and polyphenol-rich foods have all been suggested to protect against the risk of colorectal cancer. Polyphenols are compounds found in fruits and vegetables that are thought to have anti-carcinogenic properties against colorectal cancer through several mechanisms, including reduction of oxidative damage to lipids and DNA, modulation of nuclear factor genes involved in carcinogenesis and inflammation, inhibition of angiogenesis, induction of phase 1 and 2 enzymes, and stimulation of DNA repair and cellular apoptosis. In our study, we are looking at the polyphenol gallic acid. After researching polyphenol intake from fruit and vegetables for my fieldwork, I decided that I wanted to determine if there was any other food or drink that was rich in polyphenols and associated with an increase or a decrease in risk for colorectal cancer. One of the most consumed beverages in the world is coffee. It has been associated with decreased risk of breast, endometrial, prostate, and colorectal cancers. Most of coffee's benefits are thought to be due to its antioxidant and anti-inflammatory actions that may protect against diseases triggered by inflammation. It has been thought that coffee influences the colorectal health through several mechanisms, including having roles in the microbiome, motility and fecal output, inflammation, secretion of bile acids, and coffee intake also increases the anti-mutagenic properties and detoxification capacity of the colorectal mucosa. There have been several observational studies that examine coffee intake in colorectal cancer. In a case-control study in Israel, Schmidt et al. Investigated the association between consumption of coffee and the risk of colorectal cancer using cases and controls from the Molecular Epidemiology of Colorectal Cancer study. Data was collected using interviews and an FFQ which included frequency and type of coffee as well as intake of tea and other beverages. They found that modest coffee consumption of more than 1 cup but less than 2 cups per day is associated with a reduction in the odds of developing colorectal cancer, and that consumption of more than 2.5 servings of coffee per day was associated with a 54% reduction in odds of developing this type of cancer. This inverse association was consistent for all coffee intake, including boiled and decaffeinated and colon and rectal cancers. In 2 recent meta-analyses, Horasaki et al. Examined 14 Japanese cohorts studies and reported that moderate coffee intake may be inversely associated with colorectal cancer risk. Gann et al. Also examined the association of coffee intake with colorectal cancer. Their analysis included 19 prospective cohort studies involving over 2 million participants. They found that the colon cancer risk decreased by 7% for every 4 cups of coffee consumed per day, but they saw no association with rectal cancer and consumption of coffee. Not all studies have found that coffee consumption is associated with a lower risk for colorectal cancer. Grosso et al. Examined the relationship of daily coffee intake using data from the Women's Health Initiative observational study in the U.S. They used data from self-reported questionnaires that included type and amount of coffee consumed and the preparation method. They concluded that compared to those who did not consume coffee, those with both moderate and high consumption of coffee intake had an increased incidence of colorectal cancer. Also, moderate and high intake of drip and non-drip brewed coffee was associated with increased odds of colorectal cancer. There are several limitations to these studies. Many used FFQs which may not accurately depict coffee and other dietary intake. There are also lifestyle factors that may have confounded study results. Coffee drinkers are associated with being overweight or obese, smoking, and having a higher intake of red meat, processed foods, and alcohol. But let's take a look at why coffee may protect against colorectal cancer. There are several compounds in coffee that may explain why it might have a protective effect against colorectal cancer risk. These include polyphenols, caffeine, melanoidins, trigonelline, and diterpenes. The polyphenol compounds that are most associated with coffee are chlorogenic acids. Chlorogenic acids determine coffee's aroma, flavor, and quality, and coffee is thought to be the main source of chlorogenic acids in the human diet. They have demonstrated antioxidant effects by lowering inflammatory mediator production through mechanisms which include inhibiting expression of pro-inflammatory cytokine genes through oxidative stress reduction. And in 2 separate animal studies, a chemopreventative ability against colon carcinogenesis was shown in rats fed chlorogenic acid-rich feed, and incidence of colon tumors in hamsters was significantly lowered when fed a chlorogenic acid-rich diet. Caffeine is metabolized by the liver into paraxanthine and theophylline and may directly decrease colorectal cancer risk. Caffeine from coffee is demonstrated to stimulate colonic motor activity and inhibit colon cancer cell growth. Theophylline is shown to induce apoptosis in cancer cell lines. Caffeine has also been shown to have the ability to inhibit nuclear factor kappa beta cell activation, resulting in reduced oxidative stress. Melanoidins are nitrogenous brown polymers that are known to scavenge radicals and chelate metals, which may contribute to coffee's antioxidant and anti-inflammatory activities. They are products of roasting, which are also thought to act as a dietary fiber and increase motility in the colon. Trigonelline is demonstrated in animal studies to reduce concentrations of nitric oxide and malonaldehyde while increasing the activity of superoxide dismutase, glutathione, catalase, and inducible nitric oxide synthase in the pancreas. This suggests that it might induce antioxidant effects through the upregulation of antioxidant enzymes and by decreasing the peroxidation of lipids. There are 2 diterpenes, cafestol and kewal, which naturally occur in coffee beans and are plentiful in unfiltered and boiled coffees. It is not known if these have antioxidant properties. However, they have been shown to increase production of glutathione and gamma-glutamylcysteine synthase, the rate-limiting enzyme for glutathione synthesis, a vital endogenous antioxidant and a cofactor in metabolism detoxification. They have also shown that they might increase the expression of NADPH quinone oxidoreductase 1, another enzyme thought to be a part of this endogenous antioxidant system. Most research done so far has used previous data from large cohort studies. Biomarkers should be used to correct for self-reporting errors, but few studies have utilized them, and so far only caffeine and its products from metabolism have been associated with both coffee intake and colon cancer. Further research is needed to determine the effect of coffee on colorectal cancer risk and incidence in men and women.